Chapter 5, Discrete Probability Distributions. In this video, we'll learn how to calculate and interpret the expected value and the standard deviation of a discrete random variable. So a random variable takes on different numerical values based on chance. Recall we learned in Chapter 4, where we run an experiment, some random variable may occur. So for instance, on a die, the random variables possible are our outcomes, a 1, 2, 3, 4, 5, or 6 that appears on a side of a die. A discrete random variable is something that is countable. It can be finite or infinite in that I can count from 0 into infinity. Whereas in Chapter 6, we'll be learning about continuous random variables, which are uncountable infinite numbers and are measurable. So let's look at some examples of discrete random variables. Now, you can have discrete random variables that have many possible outcomes. So for instance, if you've ever worked in sales or in customer service, this is the number of complaints per day that you receive from consumers. You can count how many complaints there are, and it could, in theory, go from 0 to infinity. You can also count the number of TVs in your house. We can count the number of students in a class, and we can count the number of cars going through a toll booth. In all of these examples, we can count, and you can't have half of something, right? You have a complaint or a TV, but you can't have half a TV or half a student. The other way that we might see a discrete random variable is that there are only two possible outcomes, such as on a survey where it asks about gender, male or female, or you might be inspecting an item to see if it's defective or not, or if you're watching a game and the potential results are winning or losing. And so it's important to understand these potential outcomes for a discrete random variable because we'll be calculating the probability under these situations. So let's look at an example of a discrete random variable. Here we have real estate listings in Oceanside, California that show the homes with various numbers of bedrooms. The variable of interest is our x, which is the number of bedrooms, and the probability of each possible outcome is based on relative frequency of occurrence. So this should sound familiar. We learned about relative frequency in Chapter 2 and how we can use it for probability assessment in Chapter 4. So here's our histogram, for example, and we can see the distribution of the number of bedrooms in our homes. Our P of x here represents the probability for the houses with a certain number of bedrooms in Oceanside. So the first thing we want to do with our discrete probability distribution is to calculate the expected value. This is the mean of a discrete probability distribution. In other words, it's the average when the experiment generates values for our random variable that is repeated over the long run. So here's our mathematical formula. E of x means our expected value of x, or the mean. So we're learning another vocab term. Expected value is another way of saying the average or the mean. Here's our summation symbol, because what we'll do is we'll take each of our x values, that's the value of our discrete random variable, and we'll multiply it by our probability of that random variable, and then we'll add them all up. So what I like to do is work with tables to help organize my math. And so according to the formula, the first thing we want to do is take each of our x's and multiply it by its probability. So here's my 1. I'm going to multiply it by 0.1. So once I multiply each of my rows here across, I'll get the following numbers right here. And now according to the summation symbol here, it says we need to add up all those values. So you can see once I've multiplied across, I will add all of this up, and my expected value, or my mean, is 2.85 bedrooms. Now you might say, well, I thought you said discrete random variables is something you can count. So yes, if we look back, these number of bedrooms are something you can count. You can't have half a bedroom. A bedroom's a bedroom no matter what size, how big or small it is. But when we calculate the average or the expected value, it can be in a decimal format or partial number because we're taking the average of something. So our expected number of bedrooms is 2.85, which represents the average of our probability distribution. Next, we have to figure out how to find the standard deviation. Recall that you learned what a standard deviation is in Chapter 3. It measures the spread, or how much variation, or how wide our set of data is if we had to graph it. So here's the formula for the standard deviation of a discrete random variable. Now it looks similar to what we learned in Chapter 3, this first half right here, but there's a new component. The probability of each of our discrete random variables is now included in the formula that we will end up multiplying in our formula. So again, our E of x, that's our expected value. So we just learned how to calculate that. That's the mean or average. Our x is the various values of our discrete random variable possible. And our P of x is the probability of each random variable. Now, unfortunately, there's no Excel function that you can just plug in. You have to do this by hand or using a table, or if you use Excel, you have to create a table in Excel and set up the different formulas. So for instance, I'm going to use a table format here, and whether you do this with a calculator or you can even do this in Excel, it'll give you similar results depending on rounding. So here's our formula. So first on the left here is our number of bedrooms and our probability for each of our discrete random variables, each of our x's, 1 through 6. Now recall we already found the expected value by multiplying each of our numbers across here and then adding it all up. So we already have our expected value of 2.85 bedrooms on average. And so what we need to do in the remaining of the table is to find the standard deviation. Recall, in order to get the standard deviation though, you have to find the variance first. So you'll notice that the first two columns here is very similar to what we did in chapter 3. In this step, if we look right here, that's right here in the brackets. So it's important that we know the order of operations. It's PEMDAS, parentheses, exponents, multiplication, division, addition, and then subtraction. And so here, we're going to work in our parentheses or our brackets first. We're going to take each of our x's and subtract our expected value. So my x's are the number of bedrooms in a house. That's my discrete random variable. And then I'm going to subtract our expected value, which was the 2.85. So for instance, I would take 1 minus 2.85, and that will give me negative 1.85. And then I'll do the same for each of the rows. So I'll take 2 minus 2.85, 3 minus 2.85, 4 minus 2.85, 5 minus 2.85, and 6 minus 2.85. And so I get these differences right here. So this should feel familiar. In chapter 3, we did the same where we took each of our x values and subtracted the mean or average from it. Then in the next step, so you can see it's very similar except now we've added the exponent. So what we'll do is take each of the numbers in this column and square it. So I'm going to take negative 1.85 and I'll square it, and I'll get 3.4225. And then do the same thing for each of our values here and square it. Note that whenever you square a negative number, it turns into a positive number. A common error that occurs is that when we square it, we carry the negative over, and that will result in an incorrect answer. So remember, negative numbers squared turn positive. So now that I have each of my differences squared, we look at our next column to the right. This is the new piece. So these two steps that we just did is very similar to what we did in chapter 3. But now that we have actual probabilities for our discrete random variables, we will multiply our probabilities by the numbers found in this column right here. So you can see this column gets carried over to here, and then now we're just multiplying by our P of x. So we want to make sure we know where our P of x is. So if you look back in the second column right here, here's my probability for each of my discrete random variables. So I'm going to take these and multiply it by our squared values. I'll take my 3.4225 times 0.1. The 0.1 is right here. I'll take my 0.7225 and multiply it by my 0.3, which is the 0.3 for houses with 2 bedrooms, and so on. So when I multiply this out, I get the following numbers, and according to the summation symbol here, when I add all of these numbers up, I get the variance. Now we know that the variance is not in the original units of measure. So if you go back to the expected value, this 2.85, that's the number of bedrooms. But when we were working with the variance, because we squared it, we took it out of the units of measure of the number of bedrooms. So in order to bring it back to the number of bedrooms as its units of measure, we have to square root our variance. So I'm going to take that 1.4275 and square root it. And if you forget, it's also in the formula right here as the last step to remind us. So once I square root our variance, we get a standard deviation of 1.1948. Or if I round it, it's 1.2 standard deviations for our number of bedrooms in our homes in Oceanside. So let's go ahead and do the problem on your worksheet 5.4. This is a discrete probability distribution. you're asked to compute the expected value, the variance, and the standard deviation of x. So we're given their table right here. Our x values are 50, 65, 70, 75, and 90. And you're given the probability of each of our x values as follows. Note that the probabilities need to add up to 1. And that's according to the rules that we learned in Chapter 4 about probabilities. So I've got our table set up here. We're bringing over our x's and our p of x's. So the first thing we need to do in order to find our expected value is to multiply across and then add up all the numbers. So go ahead and pause and work through it. So once you've multiplied across, these are the values that you should get. And when I add all of this up, my expected value, or my mean, is 66. Now in the next part of our column, it says we have to take each of our x's, that's in our first column, and subtract it by our expected value, or our mean, of 66. Go ahead and pause and work through that. And so you can see each of my x's are listed here, and then I minus the 66. So you'll see here I've got some negative and some positive numbers. In our next column, we'll take what we just did and square each of these numbers, taking care that when we square a negative number, it turns into a positive number. And so we get the following numbers here for our squared differences. And in our last column, the next thing we'll do is take the numbers that we just squared and we'll multiply them by their probabilities. So we have to go back to the second column right here, our p of x's, and multiply those. So when I take each of my squared differences and I multiply it by my probability, these are the numbers we obtain. Now for our variance, and if you forget, the formula is down here for reference, we have to add up all of our values here. So when we add them all up, we get 219. Then to get our standard deviation, we will square root it. And if you forget, when you look at the symbols here, we have our sigma squared, which is our variance, and then we have sigma. So how do we get rid of a square? We have to square root it. So in case you forget and you don't have the formula in front, it's helpful to understand what the Greek symbols are saying. So once I square root my 219, we get 14.799, or I can round that to 14.80. So if you have any questions, just let me know.